name is Sherdine Alea R. Rivera, and I'm from BASC at 3I, and my subject is Dynamics of Rigid Body. So this topic of rigid body is about absolute motion. So let us read the problem. So example number 1, a wheel of radius r rolls on a flat surface without slipping. Determine A and B. So there is A and there is B. So A is the angular motion of the wheel in terms of the linear motion of its center O. The acceleration of a point on the rim of the wheel as the point comes into contact with the surface on which the wheel rolls. So this is the figure of our wheel. So as you can see, there is broken line and the full position is in the other side, which is the full line. So we have the y-axis and of course the x-axis. We have velocity direction to right direction. We have point O, point A, we have C prime, O prime, S, and R theta. So let's start to solve. So by solving, so I just have to discuss something. Well, in this figure, we can notice that the wheel rolling to the right, so this one. So in this figure, we can notice the wheel is rolling to the right direction from the broken line to the full position without slipping. The moment of the center O is denoted as S. So you can see it in your screen. Wherein the arc length CA along the rim on which the wheel rolls. Other than that, when line CO rotates to a new position, it will be a C prime. So when it rotates, it will be changed into C prime or O prime by the angle theta. So that theta is measured from the vertical direction. Therefore, the displacement and its two dimensions derivatives will give us the solution. So let's write. So the derivatives will give us S is equals to R theta, where this theta must be in radian, so rad. So radians. So we have velocity sub O is equals to R angular, and this is also equals to S prime. And acceleration O is equals to R alpha, which is also equals to S double prime. So when the point C has moved along its circular path to C prime, its new coordinates and their derivatives become, this will become x is equals to S minus R sine theta, and x is equals S is also equivalent to R theta. So simply substituting R sine theta, so just factor out the common variable, which is the R. So R theta minus sine theta. So after that, we have the first derivative of x. The first derivative of x is equals to R theta is equals to 1 minus cosine theta. And to further derive this, R theta is also, this would be V sub O 1 minus cosine theta, and the double derivative of x is equals to V, so let's just derive this, V sub O 1 minus cosine theta, so sum and product, plus V sub O theta sine theta. So we have the answer, which is VO, which is AO 1 minus cosine theta plus r angular squared sine theta. So that is our for x. And then let's now move to y. So for our y, we have r minus r cosine theta. So common factor again, r, sorry, 1 minus cosine theta. So derive this y. We will now have r theta sine theta. So this is also equals to v sub o sine theta. So y double prime is equals to v prime sine theta plus, so this is 1, plus its derivative. So VO theta cosine theta. So you just have to know their derivatives. So y double prime would be a sub o sine theta plus r angular squared cosine theta. So therefore, this will give us when, so have to remember that when theta is equals to 0, x double prime is equals to 0 and y double prime is equals to r angular squared. So here is the answer. So the acceleration of a point C depends on r and angular. To make things clear and to make things simple, when theta is equals to 0, our point of contact has 0 velocity. So that x prime y prime is equals to 0 also. So that's it for our example for absolute motion. Thank you.